Hi guys, this is Dr. G here, and in this brief video let me explain you your lab which is on drawing chemical structures. So in this particular lab the first thing that you need to do is you have to draw condensed structures from the skeletal structures that I have given you. So basically in this lab, in the first question of this lab, I have given you a bunch of different skeletal structures, and I'm asking you to draw the condensed structure for these structures and then figure out the chemical formula. So let me explain a couple of problems, and then we will discuss how to do it. Okay, so let me do the first one. Let's try the question number 1A. So when you are drawing condensed structures from a skeletal structure, the first thing that you need to know is what are skeletal structures. So in skeletal structures, every end and a bend will be a carbon, right? Every end and a bend will be a carbon. The other thing is the lines that we see here are going to be carbon-carbon bonds, right? So in a skeletal structure, every end and a bend is a carbon, and also the lines that we see here, the skeleton that we see here, are actually carbon-carbon bonds. We don't write the carbon-hydrogen labels, and also we don't write the carbon-hydrogen bonds, right? So the first thing that you need to do is keeping the skeleton the same, or keeping the shape of the skeleton the same, trace the carbon structure. So you have a carbon here. Let's start from here. So I'm basically tracing the carbon skeleton. Okay, I'm basically tracing the carbon skeleton. So if you take a look at it, I basically kept the same skeleton and then traced all the carbons that we have. Okay, every end and a bend is a carbon. That is the concept. Every end and a bend is a carbon. Okay, so as you can see, now we know how many carbons we have, and we know how many carbon-carbon bonds that we have. So if you take a look at this particular carbon, it has one carbon-carbon bond, but every carbon has to have 4 bonds. So the remaining 3 bonds should be what? 3 hydrogens. This carbon has 3 carbon-carbon bonds, so the remaining bond should be a hydrogen. This carbon should be a CH3. This carbon should be a CH, CH2, CH3, CH2, CH2, CH3. Okay, depending on the number of carbon-carbon bonds, fill out the number of hydrogens. How do you do that? Always subtract the number of carbon-carbon bonds, okay, from number 4, because every carbon has to have 4 bonds, and then you will get your answer. Okay, number of hydrogens. You will get the number of hydrogens. That is how you do it. Okay, very, very straightforward. And here's the other part of this question. I'm also asking you to determine the chemical formula. Hey, by the way, I just want to mention, some people tend to be very lazy, and then when I ask you to draw the condensed structure from the skeletal structure, they just put the carbons and then the hydrogens on the same skeleton structure. Don't do that. Okay, don't be that lazy. Don't be the guy who is going to fill out carbons and hydrogens like this. This is being lazy. Okay, and you have to draw a new structure for skeleton. You have to draw a new structure for condensed structures from the skeletal structure. And let's see how to figure out the chemical formula. Okay, so in here what you will do is you will count the number of carbons. Okay, so you have 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have 9 carbons, and how many hydrogens you can have for 9 carbons, right? So for 9 carbons you can have 9 times 2 plus 2, which is 20 hydrogens as the maximum number of hydrogens. So for 9 carbons, an alkane or a saturated compound will have 20 hydrogens. And the compound that I have actually yeah, the compound that I have has no double bond, no rings, so therefore it is saturated, right? This is saturated, so the chemical formula will be C9H20. C9H20. Okay, all right. So uh, then let me try another example. In the next example, let me try something with a ring, okay, and a double bond maybe. Um, we can try D. Okay, let's try D because you know what? Let's try J. J is the most complicated one. I wanted to leave it for you guys, but I think it is better to explain J rather than you trying it. Okay, so the first thing that we need to do in J is to draw the condensed structure. Okay, so draw the condensed structure. By now you know every bend and every end is a carbon, right? So you can basically trace the carbon skeleton. You can basically trace the carbon skeleton. This is the carbon skeleton for your skeleton structure. Okay, but the carbons that I put there, those should be hypothetical. Okay, don't actually write them there. So draw the carbon skeleton in a separate structure. Carbon, 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 carbon. So this is your cyclopentene ring. Okay, this is your cyclopentene ring, and then this carbon is actually the carbon right here. Okay, this carbon right here is the carbon right here, and then you have another carbon going down, another carbon in this side, carbon here, carbon here, carbon here. I always try to leave some space to write the number of hydrogens. Okay, a carbon and another carbon. Okay, so we have the carbon skeleton exactly as our skeleton structure. Okay, so let's erase these because we put them to have a guidance. And now let's put the hydrogens here. So if you take a look at this carbon right here, okay, it already has 3 carbon-carbon bonds. It needs 4 bonds and it already has 3 bonds. So how many hydrogens should it have? 1 hydrogen. And this carbon right here has 3 bonds already out of the 4, so it should only have 1 hydrogen. This carbon has 2 bonds out of the 4, so it should need 2 more hydrogens. 2 more hydrogens. CH, CH2, CH, CH3, CH2, CH2. This carbon already has all 4 bonds, so there should be no hydrogens. And if you take a look at this bottom carbon, it already has 2 bonds, so it needs only 2 hydrogens. CH2, CH3. Okay, so we just drew the condensed structure for the skeleton structure that we have in J. All right, so let's do the chemical formula. Okay, let's do the chemical formula. So you have 5 carbons in this ring: 6, 7, 8, 9, 10, 11, 12, 13. Okay, so you have 13 carbons in total. So you have 13 carbons. For 13 carbons, if you have the maximum number of hydrogens, how many hydrogens can you have? 13 times 2 plus 2, which is 28. Okay, if some people have their mouths open, that means they don't know the general chemical formula for alkanes. Okay, general chemical formula for alkane is CnH2n plus 2. Okay, we use that. I mean, we know how many carbons we have, which is 13. We multiply it by 2 to get the 2n, so it is 26. Add 2, it will be 28. Okay, so this is for an alkane or a saturated compound. But is this saturated? No, this compound is not saturated. This has a few features. Okay, this has a few features. It has 1 ring. It has 2 double bonds. Am I correct? Right, so 1 ring takes up how many hydrogens? It takes up 2 hydrogens. 1 double bond takes up 2 hydrogens, but we have 2 double bonds, 1 here, 1 here. So we have 2 double bonds. That means each double bond is 2 hydrogens. So the 2 double bonds are going to be 4 hydrogens. So we have to subtract a total of 6 hydrogens from the 28 hydrogens. From the 28 hydrogens, we have to subtract 6 hydrogens. So our final formula will be C13H22. C13H22. This will be your final answer. That is how you do it. Okay, so now you should be able to do all these questions by yourself. Okay, do all these questions by yourself. So let's go to the next page. Okay, so in this question, okay, I hope that you guys are paying attention, because I mean, this is literally all you need to do. Okay, so you are learning a lot in a few minutes, so please pay attention. Okay, in here I want you to draw condensed and skeletal structures for the following compounds. Okay, by the way, there is a couple of mistakes in this question, so I will highlight it when I do it. Okay, the first mistake that I have is that I'm missing a hydrogen in this location. I'm missing a hydrogen in this location, and I'm missing a carbon label in this location, this location. Okay, that's the mistake that I have in here, so you might want to mark that down. Okay, you might want to mark that down. So you in this structure you have to draw the condensed structure and the skeletal structure. So very easy. Okay, so when drawing the condensed structure, what do? We keep the carbons as is. Okay, and then we don't draw the carbon hydrogen bonds. Instead we put the hydrogens on the carbon. So this will be CH3. This carbon has 2 hydrogens. This carbon right here has 2 hydrogens. Keep track. Okay, this carbon has 2 hydrogens, and then the next carbon has 2 hydrogens. So you can trace it like that, or you can simply count the number of carbons: 1 2 3 4 5 6 7 8 9 10 11 12. So I mean, this is a straight chain compound, so have all 12 carbons together. So CH2, 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 1 2 3 4 5 6 7 8. So it's 4 more carbons: CH2, 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 and CH3. So this is the condensed structure. So how do you draw the skeletal structure? You only write the carbon-carbon bonds, right? You only write the carbon-carbon bonds. So what you can do is you can draw a 12 carbon skeleton structure, without carbon labels, hydrogen labels, or carbon hydrogen bonds, right? So start from here. Okay, so I'm basically trying to visualize this structure with only carbon-carbon bonds. So you will have this bond, this bond. I mean, you can highlight the carbon-carbon bonds that you have, or what you can do is you have 12 carbons and it's a straight chain carbon. So start counting: 1 2 3 4 5 6 7 8 9 10 11 12. Okay, you have 12 carbons and you only kept the carbon-carbon single bonds. Okay, let's do one more. Let's maybe try C. Let's try C. C looks like a nice question. Okay, so let's try C. Okay, this is the last one that I do. So pay attention. Okay, pay attention. All right, so in here we need to draw the condensed structure and the skeletal structure. Okay, in condensed structure what we do is we don't write the carbon hydrogen bonds. Instead we bring the hydrogen to the carbon. Okay, we bring the hydrogen to the carbon. So let's start with this carbon. I mean, let me label the carbon so that you will be clear. Okay, let me label the carbons. This is carbon number 1, carbon number 2, carbon number 3, 4, 5, and 6. Okay, so let's start with carbon number 1. So it will be, the carbon number 1 will be what? It's a CH. Of course it's a CH, and it has a triple bond. Okay, sometimes people might write the hydrogen on the next side. That is perfectly fine, both are correct. Okay, CH, and then you have the second carbon C. It doesn't have any hydrogens, and then a C. It has a carbon-carbon double bond, and then carbon number 4 is a CH2, and carbon number 5 is a CH, and then you have a double bond, and then you have a CH2 as carbon number 6. So this will be your condensed structure. And how about the skeletal structure? Okay, that means you should not have any carbon hydrogen labels, right? You should not have any carbon hydrogen labels. So basically what I'm asking you to do is to remove all the carbon hydrogen labels, uh, from the skeleton, right? I love teaching this part from this notebook. Why? Because all you need to do is to remove the carbon hydrogen, what? Carbon hydrogen labels. See? So I just removed all the carbon hydrogen labels, and this is the carbon bonds that are left. Okay? So just connect them. Just connect them. See? This is all you need to do. But I mean, this is a messy one. I mean, we just erased. I mean, this is actually for the people who couldn't visualize the structure without looking at the carbon hydrogen labels. But what you need is a carbon-carbon triple bond as the carbon number 1 and carbon number 2. Okay, and then the carbon number 2 extends to carbon number 3. And then you have a double bond. And then you have a single bond to the bottom, and then another double bond. Okay, another double bond. Okay, let me draw the labels. Okay, so you don't need this. This is imaginary. Okay, this blue ink is imaginary. This is carbon number 1 right here, and right here is your carbon number 2. Right here is your carbon number 3, carbon number 4, carbon number 5, and finally carbon number 6. Okay, so this is all the carbons, but you don't need them, so I'm going to erase them. Okay, but if you want more time to see what are the carbons, you can pause the video, of course. Okay, all right, so this is your skeletal structure. And the other thing is I'm asking for hybridization. Okay, and I actually explained it in a previous video, previous lecture video, but let me remind you what are hybridizations. So we have three hybridizations. The first one is called sp3. The second one is called sp2, and the third hybridization is called sp. Okay, so if a carbon only has single bonds, which means it is an alkane carbon. Okay, alkane carbons are going to be sp3 hybridized. If a carbon has a carbon-carbon double bond, that carbon has the sp2 hybridization. If a carbon has two pi bonds or a triple bond, okay, that carbon actually have the sp hybridization. Okay, so let's look at the hybridizations. Okay, so C1, carbon number 1. Let's write it like this: C1, carbon number 1. Okay, what is the hybridization? It has a triple bond, so the hybridization is what? sp. C2 has the hybridization once again sp. C3, it has a double bond, so it is sp2. C4, it has a double bond, so it is sp2. And C5 has a double bond, so it is sp2. And C6 has a carbon-carbon double bond, so it is sp2. Okay, so this is how you do the hybridizations. Very straightforward. Okay, all right, I hope you guys learned something. Okay, the one last thing that I want to mention is the structure D. Okay, in here you have a nitrogen. Okay, so this is something that I want to highlight to you. Okay, in here you have a nitrogen, so and also an oxygen. So whenever you have these type of atoms, and I'm missing a hydrogen label here, you might want to note that down. Okay, so whenever you have an atom other than nitrogen, or I mean other than carbon or hydrogen, when drawing the skeletal structure, you have to write that label. Okay, so let's start from carbon number this carbon. Okay, let's start from this carbon right here. So in the skeletal structure, you will have a carbon with a double bond to an oxygen, so don't forget to write that O. Okay, and then this part right here is the R. Okay, so I'm going to say this is R, and then that carbon also goes into a nitrogen. Okay, So draw the nitrogen out, okay, because we only don't write carbon and hydrogen labels. Nitrogen is a different atom, so we need to write the label. That is important, okay. And then a triple bond to a carbon, so don't write that carbon out, and it goes to another carbon, it goes to a double bond, okay. This is that double bond, okay. Are we good? And also this OH, I mean, when you're writing that OH, when you're writing that OH, this carbon goes to an oxygen, but this hydrogen is on oxygen, right? So since that hydrogen is on oxygen, you have to write the label. That is important. You have to write the label, okay, and then you can continue. All right. So I hope that you guys learned everything there is to know about drawing condensed and skeletal structures, and this lab should give you a nice practice on how to actually draw condensed structures, skeletal structures, and also how to predict hybridizations. Okay, please let me know if you have any questions. You guys have a nice day. Okay, take care.